Thank you so much. Thank you everyone for attending. This is Unlimited Power with TCP at VetSec 2020. Thank you so much everyone for attending. So just to let you guys know, I'm going to stop at various points so we can have some questions, some Q&A, because we're going to be diving into some code. You may not be familiar with it, and I'm here to help you with that. Yes, unlimited power, that's right. And you'll see it. There's a slide on it. So let's talk about the presentation highlights. First, we're going to talk about what DevTCP does. Some of you may already know. Then we're going to talk about tricks. If you're new, you might not know that, but if you've been around a while, these will be familiar. And this is just to give you an idea, a flavor of what that power is, but not the unlimited power. And then we're going to talk about me, who I am. And then what is DevTCP really? And this is a tricky one. Very few people know what it is. You really have to dive deep to understand what is actually happening. You think you do, but guarantee you don't. And once you know what it really is, that's when you get that unlimited power. And then stealth, obfuscation of the future. With Bash and DevTCP, you can use those in combination to unlock stealth, so you can't be detected. It's not perfect, there's always a way. Obfuscate, make it harder for defenders to see you. And if you're a defender, now you'll know some ideas on how to go out about reversing that. In the future, there's some new things happening in the world. And, you know, Bash has been around for a while, but Bash has some opportunities with what's coming forward. And once again, you'll see some question marks. And when you see those question marks, I'm going to go in the chat, dump in your questions, and I'll go ahead and start answering them. So save them up, and I'll just look in the chat when we get to the question mark slides. So DevTCP, what is it? It's garbage in, garbage out. DevTCP right here, it's like a file. When you write into that file, you're sending information over a network, possibly over the internet. And then when you read from that file, you're reading from that socket. You're reading that information. Some of you may have done this in Python. You might have toyed around, done a little bit in Bash, but just like a quick thing there, quick thing back. But you're going to do so much more here. And this is Bash only. So you might have thought, oh, I could do this in like KSH or ZSH or anything like that. You can't. At least not natively. The reason being is it's a special Bash feature. And not every Bash has it. So what does it do? It's a clock. It's a browser. It's a netcat client. So here's a quick little demo. You may see this on the internet. Just go talk to that time.nis.gov port 13. Some of you may know what that protocol is. And bam, you got the time. It's a browser. You can go in here, open up a port, talk to google.com, port 80. HTTP 1.0 is easy. You want to do 1.1, you just got to type a lot of headers. It's going to take a lot of slide room. So here's just a very easy HTTP request, talking to that file descriptor. And then you go ahead and you read from it. And I just wanted the first 10 lines. I didn't want to blow up the slide. But here you can see that HTTP response. And like any good citizen, you will close your file descriptor when you're done. We'll go into why that's important, but trust me, this is key. Netcat client. So I wrote a quick little bash cat. Here you can see function bash cat, no files needed, just stored in your local session, your local shell. First, you clear out your FD in case you set it up before, and then you go ahead and you go and you create an exec and you open up that TCP port. But now you're going in and out. That's what the less than and greater than is. It's like the opposite way. And then you go ahead and you say, hey, read in and read out to that FD. And when you're done, close it. And then here you can see in this chat, you talk from the top to the bottom. Then this guy types in bottom to top, and then he writes that. This was interactive. I just did this a couple of days ago. And another important thing to note here, go back. This guy, once again, you always got to unset it. Oh. All right, moving on. So what else does it do? Okay. Port scan, that's right. You can download a file and reverse a shell. So if you start Googling, you're going to see examples of all three of these. I mean, that's just reference. Just Google it. You're going to see reverse shell, tenant style, you're going to see files downloading over HTTP, or if you have a netcat server, just pumping out that file, it'll go ahead and get it. And yeah, you can write your own port scanner. So if you're in a situation where netcat isn't available, Python's not available, but you got a bash shell and you have dev TCP, you're in business and you don't have to use a proxy. You just take it off from that host. And then, yeah, your own custom program, Hackerman style. That's right. You need to write your own program with dev TCP. It doesn't have to be bash one-liner. And with that, you can start deciphering plain text protocols and or not plain text, and send your transmission out and get some transmissions in. It could be for an exploit. It could be to scan for a vulnerability. It could be to scan for open usernames, as we will do here. I wrote a custom program just to demonstrate it. But first of all, who am I? I'm Brian Davidson, Director of Software Development. Career has been about 10 years. You know, post-military. I'm a USMC veteran, so spent a little bit of time deployed to Iraq. Time really taught me a lot about leadership. It's helped my career. It's made me improvise, adapt, and overcome, which is key with Bash. You are going to face failure after failure after failure, and it'll drive you nuts. And that resilience you get in the military is key for being successful anywhere in the technology field. I was an economist, which really meant I was a programmer who did numbers. That's all. And I have some SAN certificates, GCIH, GPEN, GMOB, GWAP, so much more. I'm a new father. I got heavy into cybersecurity about 15 months ago, right when my kid was born. And, you know, I've come all the way since. So much more to come. Always busy and learning. Please reach out to me at the end. You'll see all my contact information, my GitHub. Please reach out if you're interested in anything I've talked about or if you have questions. So where is dev TCP? This is the big mystery. These guys don't know. And dev, everything's supposed to be a physical device. And if you look up here, you're going to see what, like a DVD somewhere, or CD-ROM, TTYs. But where's that TCP? You guys see it anywhere? It should be like somewhere around here, but it isn't. It's not there. But you use it. A lot of you have used it. I've used it. So how do you get access to it? Let's talk about sockets. Step one, you open a socket. So down here, you can see I have some netcat and I'm looking for it. And here we find its PID. That netcat session, you now go into the proc, the PID, and find the FD in this directory. And here you see this socket and it's got this magic number there. This magic number is key here for one reason only. That's the inode. Your computer has a limited number of inodes. I don't care how much disk space you have. You can open up, every file has an inode associated with it. You have 1 million terabytes. But if you reach the maximum number of files, maximum number of inodes, you can write no more to your disk. And every time you open up a socket, you have created an inode. That inode allows you to access the file metadata. That file metadata is like, where is it? How big is it? It's everything your operating system kernel in Linux and maybe one day Windows needs in order to access that file. And in Unix, everything is a file. Your screen is a file, your socket's a file, your text is a file, everything. So let's talk about these devices and how they map to files. And this is the key information for that. So up here, this is an excerpt from devices.txt. It's from the official repository for Linux, Linus Torvalds little repository. And here you see this 30, you see this 36. Questions are coming up shortly, I promise. So you see this 30, you see this 36. That's your major and your minor number. It's this map inside of the Linux system. And you see this character. Those are your key pieces of information. That's how your system knows that I have some sort of character device that's 3036, and that's dev inet TCP, and there's for UDP as well. And then, if you wanted to make it yourself, use makenode. And here's the excerpt from the man page. You go makenode dev TCP, and that C maps to the character, which means this is a file that operates on one character at a time, a device that operates on one character at a time, which is a file. major 30, so it goes here in the devices.txt, and 36, which is dev and TCP. So if you look in Linus Torvald GitHub, you'll see this. You go to TODP, there's something that explains how this make node works, and there's a man page on that. So, now we're getting to unlimited power. So, step one, write your custom code. Now you got this bash program that can do whatever you want. And I'm going to show you an example of that very shortly. And you can rip off my code, use it to make your own custom bash code that talks over the network. It'll handle everything. Take baby steps. So with bash, it's frustrating. If you jump and you write more than a few lines of code and you go and think it's going to work, I'm sorry, buddy. It's not. You're going to fail. I failed. I can't tell you how many times I failed. So you take baby steps. You write that if statement, you're not sure if that's working, or if you're sure it's working, you try it out. You just type in your shell. That's bash is interactive. It's awesome. Take those baby steps. Always baby steps. And RTFM. Read the F manual. You will have to do this. It's better than Stack Overflow. And I'll just step to the side so you can see these URLs, but I'll put this whole slide deck up on OneDrive so anyone can download it. Right after this, I'll put in the chat. So RTFM. So there's two great sources. One is the bash manual. That's right. And then number two is the advanced bash scripting guide. I refer to it all the time. Anytime I write bash code, I don't care if it's an if statement. Oh, and I'm not sure, I look it up. Just RTFM. So let's talk a little bit about why bash is awesome. So you got pure shell and take it anywhere with you. And where there's bash, you got this. Sometimes you don't have to write Python. Sometimes, let's also talk about reverse engineering. So you're going to reverse engineer a protocol to write this some limited power. And now, another thing is ABC. Always be coding. If you're going to get good at bash, you're going to get good to write this. Got to code every day. Now, got to take a break. That mental health thing, don't burn out, but do something small. And you may find yourself a couple hours later doing a lot more than what you initially set out to do. The ABC, always be coding. And on top of that, ABCD, always be consistently documenting. Write your own personal wiki. Atlassian has a great wiki. You put up some code and you didn't put it in GitHub, just put on your wiki. You're going to refer to it later, I promise you. And it's going to save your bacon, save you hours of time. And now, here's the demo. So here's the usage. So this SMTP bash, first you put in your IP, the domain, optionally, like say @domain.com or @gmail.com, -w. So this IP, by the way, is the SMTP server you're going to attack or inspect. Only do this with permission or on your own lab. The word list, so it's going to be like RockU, and I want to demonstrate this with RockU. -f if you want to go fast, as in multi-threading. And Z is if it's compressed. Sometimes you get these word lists in their retard GZ. And then the other important one is you see this at the end, right here. This username 1, 2, space. So space delimited usernames. So these are the usernames that you are by default going to try if you don't have a word list. Well, actually, it does both. And here's the demo. I'm going to walk you through the power of it. And then we're going to go through the code. It always helps to see what it looks like in action. So this is the first mode, and I'll show you the second mode in a second. So it's going to go out, connect to this IP up here, this guy right there. It's going to try a bunch of @domains, and these are the ones: admin, test me out, who am I, and for instance. So first it does the first test. Does verify even work? And yeah, it does. And now it's trying EXPN, and it's not going to work. When it doesn't work, it's not going to try it again because it's going to remember that and only use the verify. And then bam, look how fast that was. And then you see, what is this 252, that's a success. This up here, yeah, 550, that's a failure. We're going to want to grep out these 252s, and we will. So there's your egrep, and it's going to give you your answer. right about now. Oh yeah, and test1.log, because we teed it into test1.log. I'll go and show you. Let's go back so you can see that. So at the top, you see that T test1.log. If you don't know about T, you should get to learn a little bit more about it. It allows you to run a command, see it in your standard output, dump it in a log file, and then you can use grep on that log file later. So it's the best of both worlds. You're going to use it all the time. So here's the fast mode. So in fast mode, it's got this raw keyword list, you got a main, and that's going to go out and make that first connection. Test if it even works, because that's a good practice. For you start brute forcing with 10 different child processes, you want to make sure that, hey, can it connect? Does it work with the protocol? And then go ahead and hammer it with 10 different connections. Go ahead and do that. All right. So off they go. And they are storming away. While we do that, I'm just going to take a quick look at the chat. Yeah. All right. So back to the camera so I can see you guys. All right. So now look at this. All this spam that's coming through, it's reconnecting. Yeah, because after about like 20 attempts, it seems to be kicking you off. And there's attempt number 1. It's reconnecting. So now let's do a little bit of math. We got raw queue. There's a lot of words in it. If you want to do this, and you know it's 1 per second, 10 child, multiply that out or divide it. It's going to take 166 days for just one connection. So it's a 10 times speed up with this, which means it takes about 16 days and 14 hours. And you know, if you did a little recon, figured out how many max connections it could take, if you have to maybe parallelize amongst different machines and split up your word list, you might be able to go a lot faster. I mean, also it'll be a lot noisier, but a lot of people don't monitor things. So yeah, it'll just keep going. This one would take about 16 days at this configuration running. You know, I only have an hour, so we'll just stick with that. Yeah, so proxy chains, it'll take forever. And yeah, my GitHub will be at the end. I'll show you all that information. It's all on the slides. I'll put the OneDrive in here, so you'll have all this information. So let's keep going. So what happened on the other side? So you saw the attacking machine, but what is going on behind the scenes? So here's a lab demo. I mean, I'm not going to make this one giant. It's just using Docker. It starts up an SMTP server. It's a different VM. And here we go. Here's that initial connection. So you see 2 connections. So first I do 1 connection to see, hey, did the port even open? And if that didn't work, the program actually exits. And then here's the second one where it's actually really going to send some traffic. And then here it disconnects after that. And then bam, all those children are connecting. And just wait a second. It's going to take a few seconds to respond and say, hey, I'm an SMTP server. Cool. What's your name? And I actually don't even say my name in this one. And then off we go. And this is all the traffic, those 550s. If you're really quick, you might see a 252. And that's what it looks like on the other side. And we're going to talk a little bit more about the lab too. And there's a great gentleman, Mr. Santos, who has a talk tomorrow about labs. I've listened to him before, and I highly recommend listening to his talk. So questions. You got those questions, just dump them in the chat right now. I'll wait a minute and see what you guys have to ask about what you've seen so far. And then we're going to go ahead and dive into the code. So let's see if I see anything in here. Yeah, so Calvin's used DevTCP for reverse shells. Very useful. Unlimited, yeah. Thinks you might get caught. Yeah, I think the 3DS was from 4. All right, so no questions at this point. I guess I'm very clear. That's great. There'll be a couple more breaks for questions, because I don't want you to have that question and be holding on to it for too long. So now we're going into the bash, and it's important you think about this. Losers quit when they feel pain. Jacob, great question. I would suggest Googling that one. There's so much that's better than what I would do in like a quick minute or two. Tons of examples on that. Verse shells are all over the place. Super abundant. It's a quick one-liner. So with bash, losers quit when they feel pain. That's right. And Marines quit when the mission is accomplished. I don't know who wrote this, but I know he never used bash. Never. Because for your own mental health, you're going to quit. You're going to walk away and come back to it. Maybe go to sleep if it's like a little late, like 3 a.m. I've done that way too many times. So you got to walk away. Otherwise, you're just going to keep making it hard. You might be making more bugs in your code if you keep going. So quitting it it's like a tactical retreat. You're going to come back and attack from another angle. But you got to get that rest and come back later. Otherwise, you're just coding yourself into a corner, and you're never going to get out of it. Bash is hard. So there's problems with quoting. There's like every quote on your keyboard is valid in bash, and it all does something special. There's absolute and relative paths. You're going to get bit by using relative paths. Always use absolute if you can. About 10,000 ways to write an if statement. And I'm not kidding. There's like 1 bracket, there's 2 brackets, there's no brackets, do with quotes. I mean, they all work differently, and some will have strange errors, and some aren't the right way of doing it. Will your code run? Will it even run tomorrow? Maybe there's an environment variable that screws it all up. And you have to learn about file redirection, pipelines. And I mean, honestly, sometimes it feels like this language sucks, but it's everywhere. This is the ultimate living off the land. You use this tool and you're a winner. Python, they might have what, 2.7, 3.0, 3.1, whatever. And maybe they don't even have Python. Maybe they're watching for you using Python because that's what everyone uses. But not everyone knows how to do bash. You attack from the hard places. And then networking. It's hard. How do you open a connection? Not just like a quick, I want the time from NIST. How do you actually open a connection and talk back and forth? Did it even open? Did it stop in the middle of writing or reading? And clean up. And did I even clean up right? Because if you don't clean up, you might trash your computer and have to reboot and lose everything. And maybe you're trashing a computer that you got access to, and that's a problem. You don't want to do that. So let's talk about opening a connection. So first, you're going to have a file descriptor. That's at FD over there, right here. And then you're going to dump the error down into dev null. Yeah, Calvin, that's true. But you'd be surprised in production centers. I've seen lack of Python 3. It's out there. Not everyone's as fast as where you've been at. So you're going to output that into dev null. And then you're going to test, hey, did this work? And that's what this $ question mark is. It's the last command. Did it succeed or fail? And then you're going to echo, hey, that connection attempt failed to your standard error. And then exit. Because if you didn't open that initial connection, what's the point? Now here's exec. And there's something really tricky here. 99% of the time when you see exec, it's executing a command in a subshell. Now, I'll give you a second. Do you see any commands here? Yes, no? Anyone see a command? An actual command like ls, who am I, present working directory, anyone? There's no command here, 0. So in this bold section right here, this is straight from the man page. If no command is specified, redirections can be used to affect the current shell environment. That's the beauty of this. What's happening is right here, this little circled area. You are now opening up a file descriptor that's connecting to TCP, and now you can use it in your current shell. And this is the magic that makes everything happen. So, what else is happening here? So, you also need to close. No, sorry. Here you see this var name thing, right? See with these little curly brackets. And normally you see a $, you're probably WTF like me. And I've always looked at this and just assumed, cool, it works, right? And at the time with Bash, that's what you were like, oh, cool, it works. I'm gonna just go on and do what I want to do. But if I want to show this to you guys, I actually want to show you what it means. So IRTFM. And here's what it means. If var name is supplied, your redirection persists beyond the scope of this command. So when you do this little thing, this FD is now accessible later on in your program, and you're going to use it. And now you can write to it multiple times, read from it multiple times, write and read, back and forth. That's what we're going to do. And here, we're going to use some functions. Always use functions. So log error, you don't need to constantly be writing file redirection. So just make a little function, just copy and paste this. This works. It's in my GitHub. All this stuff is in my GitHub. So you're going to echo that error right here, and then you log error. Then you got this test connection attempt, because you're going to write multiple connection attempts. I would hope so. And here you're going to, check your return code, get the message, and then log error your message. So this is like your custom message, depending on the context. So you can be like down here, show you the example, right? So you unset the FD, always unset your FD in case it was already in use. Then you're going to exec and open up that connection. And here you actually pass in this guy right here. And the reason is, when you actually, if you were to do that $ question mark in here, it actually wouldn't work correctly, because it's the context of the previous command. It's a got you, and it will get you. But you also want to use functions. So that's just something you have to remember. And you just say error can't open connection, and here it'll log that error. Damn, they call each other. But let's continue on this opening connection. Hey, did the connection even work? We had that first thing, did the exact work, but is the connection even open? And then we got to clean up and understand POSIX signals a little bit. Like I said, there's a lot going on here, and that's why it's very frustrating. You got to take these baby steps. I learned this one baby step at a time, and so will you. But you have a better guide here than I did, for sure. So here you got this cleanup function where it's going to use this to close the left and the right file redirector of this file descriptor. And then here hey, is this file descriptor around? It's not. It didn't work. Something fundamentally messed up. And then here, you actually say, hey, we're good. The connection is established, and I want to trap and use cleanup when any of these signals occur. And we're going to talk about these signals. So these are all the signals that mean your program quit. We do not have kill -9. That's a death kill. If someone's going to kill 9 you, they're desperate. Do not get in the way unless you have a very special reason. Kill 9 is like the act of desperation. And that's why you don't kill 9. Because think about it. Say someone's launched 1,000 of these guys, right? And they have a cleanup function. You want to just kill it, so it has a chance to clean up. You don't kill it. What's going to happen is you got 1,000 inodes that are never going to be cleaned up, and they're off. And that's now your problem. What if it's 10,000? What if it's 100,000? I'm actually going to show you some bad code that would create a shitload of these inodes and cause problems. And if you kill 9 it, you pretty much trashed your computer and you're going to have to restart. So, questions. And then we're going to get into the real cool stuff. You thought that was cool, it gets even crazier. So, yeah, it's exactly like a fork bomb. You're kind of getting to something you're going to see soon, something real fun. And a fork bomb with network connectivity is a fork bomb on steroids. So, any questions at this moment? Give you guys 10 or so seconds to write down. If not, we'll just keep going. Yeah, I like the Riddler. I think he's great when you have a question. It's like, riddle me this, riddle me that. Hopefully you guys aren't too hard on me. All right. So it sounds like no questions. Great. So now we're going to read. All we did right now was read. I mean, we didn't even read yet. We just opened a file descriptor, checked to see if it was open. And you guys are like, wow, my brain is already melting. And there's so much more. And this is why I said unlimited power. There's so much you have to think about with this. But what you can do with it is unleash your own creativity. Now, part of that is reading. You got to read from the file descriptor. So let's move that guy over. So first, in Bash, it's really hard to return a value. I know it's silly, but like if you echo something in your function, that's what is returned. And that makes it hard to log something as part of your shell script. And then also return some variables that provide meaning to the user. So you do, very handy little thing. Just normal way of doing it is you just declare a couple variables, old school C stuff. And then initialize it every time you open it up. Very good practice. And then you got your message you're going to send. So someone's going to have read FD, and this send message is just what you were, like some kind of verb that you want to log. Say, I did a VRFY response, and then you log in the IP, the port, and what you actually got from that file. And then here, this guy's key right here, this read-t. Actually, let me make sure I'm not going over the next slide. Yeah, so that read-t, that's important. A dash T is about interval, and we'll go over that in just a quick second. But if you without it, if you don't have something immediately returned, that read is going to fail, and you do not have a message in. And then here, once again, we're testing, hey, did this read work? And here, you see this funky thing here? This is shell parameter expansion. What it does is it takes that message in, puts it all in caps. That's these two little funky things. Google it. Or look in the man page in RTFM. There's a whole host of these things, and it's even more complicated than this. Here, it just makes everything caps and checks with a regular expression, was there an error? If there was an error, we're saying, hey, what we tried just did not work. And then you say, we failed. And then whatever call this can now do something about that failure. Like say, hey, what we tried did not work. Don't try it again. And that's where the EXPN that you saw in that first demo where you tried it once and it didn't try it again, that's how it knew. And then you're just going to say, hey, this is the response. So we can grep it out later and do something more fancy. So what is read? So this is straight from the man page. It reads a line from standard input normally. But this little redirector, it's not reading from standard input. It's reading from the file descriptor, which is your dev TCP connection. And this little guy, this little Pac-Man thing, think of it as like he's munching on this data and he's like defecating the data out into your read or your message in. It's a good mnemonic to remember. Shitty humor, I guess. So that read and this -r, it's not read. So you might think, oh, I'm reading into message. No, it says do not allow backslashes. So we want to actually take those backslashes into this variable. We don't want to see a /n and actually think it's a new line. It might actually be a / and an n, and you want to do something with it. And then here, there's a read the -t with the interval. That's a timeout. So you're going to want to put a timeout in here if you expect it might take a few seconds for a response. Very common when you're attacking that the configuration is, hey, if someone's spamming me a lot of commands, give them a little bit. And we can be smart with our thingy caps and get around that very easily. Now, we want to write that connection. Writing is very easy. You just use echo. So here, drop all the way to the end, and this is where we actually do that right. We're going echo -n-e. That allows you to interpret escapes. So if you want to put a /n in there, you put it in there. If you don't want to put it in there, you don't put it in there. And the -n means do not append a new line. So that allows you full control over what you're writing when you use this command. With that, full command is your second parameter. Command name is 1. That's just for logging purposes. Always write good logs. It'll save you so much trouble. Gives you a lot more flexibility with grepping. Say you have 10 of these logs open, and you want to grep through them all. Now you know what command worked on what host, for instance. If you didn't do that, it gets a little bit more complicated. Maybe you put in the file name, maybe you didn't. But here, it's easier. Now, how did you get these variables, like the IP, the words, the flag? This is just a small sample of my options code getops. This is the standard way of doing those dash options in bash. So -i, the IP, maps to this guy right here, this IIP, which also maps up here. It says I in the colon. And you see this W in the colon? That colon means is there's something after this letter. And that something is an argument. So it will expect that opt-dog, or otherwise get ops will throw an error and not work. Same thing here. And so that's how you get that -w space rockU. You get that path in here, now you're ready to go. And this Z means it's a flag. So there's no special thing I'm taking, no parameter after it. But I want to know, hey, they put Z, I'm using zcat instead of cat to open the file. And then you see this shift thing here, right? What this shift opt-in is doing is it's saying, take the index of everything we've read, dump it out. I only want what's left. What have I not processed? And if you remember from our usage, you have a space delimited list of users that you want to test on. And here, let me move this over. Oh, didn't move it over. It's just next slide. So I was just stuck. You see this then here. So if there are users that came after this, then users is equal to that. So you're actually pulling in and storing all those usernames that came at the end of your command line. So recursion, we're going to talk about recursion. That's how this works. But there's a fatal flaw here. Something is wrong. So when you're reading this code, and I'll point it out when we get to it, but while you're reading this, look, there's something wrong, something that's going to blow things up. And I've alluded to that throughout this conversation. But this is actually what I did at first. And I was like, oh, wait, I messed up. I need to go back and revisit. And we'll go back and see what I did that actually works. This is a great demonstration of recursively calling your same script. So here's what it's saying is, hey, do I have a word list? Awesome. Get a count. Maybe you would exit out if there was just 0. And I just got rid of that since there's only so much room on the slide. And here we declare an associative array. What that means is next word list is a special variable that I can use an index on. It could be a letter or a number, a word, whatever you want. Here I'm using a number. So here we're going for every user in this word file, and this could have been cat or zcat. That was what we were showing you before. Add that into this. So for the first guy, this word's counted as 0, and the first word is going to be Bob, and it says word 0 is Bob, and then it increments. And then say we come back through again, it's Bill, and then it's princess, and it's dog, and so on and so forth. You're going to get all those words, and then we're going to keep incrementing from 0, 1, 2, 3, 4, 5, 6, 7, until millions and millions of numbers, whatever your max word count is in your dictionary file. And then here, every time you get 10 users, it's going to make a recursive call. So million divided by 10, yeah, that's how many inodes we're going to open here, and it's going to blow you up. Don't do that. But when I did it, I saw what was happening. I was like, whoa, we're going to stop this guy, because I was logging. When you log, you can see these things a lot easier. And then here, every time you get 10 words, you're going to unset this guy right here, your word list, so that you have a blank slate and it can accumulate more. And then you make a new one. And then here, you're just going to go ahead and get the next 10 and the next 10 and the next 10. And every time there's 10, it resets and sends out another. Very simple recursive logic, parallel power unlocked. So yeah, you want to see the meme, very, very funny meme there. You're a dog, I hear you like recursion, so read this again from the beginning. You don't know much about recursion. Basically, it's saying I'm a program or I'm a function that I just call myself over and over again. And that's the power of recursion. People get it wrong all the time. I did. So let's go over that recursive call, just so you can see that this symbol and word soup, what does it mean? The important thing is to know, yeah, this line you can pretty much ignore. This is easy. You're calling the script with the first 2 parameters. But what is this? And what is that? These are backticks. What that means is process between the backticks and whatever that text is, put it here just like it was plain text. So this will turn into like Bob, Bill, dog, princess, etc., 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 with 10 names and dump it out. So this is like a little for loop from sequence 0 to the maximum number in the next word list. That's what this means. So from 0 to 9, 0, come in here, echo out, no new line, the first one, then the second, the third, the fourth, the fifth, the sixth, etc., etc. And that's how it works. It's a handy little thing to know. And then that at the end, that's danger zone. Think about it before you use it. That will background your process. And that is how you fork bomb yourself. Who hasn't done that? So let's talk about the right way of doing it, the perfection way of doing it. So you use buckets, 10 buckets. And these are your 10 children processes. But they need some way of getting that data from the main process that's going to hand out those names. So first time, oh, all right, there we go. So first time you use this, you go Bill, Bob, dog, dragon, princess, root, admin, yada, yada, yada. And then it's going to go back and write more and more and more. Same time, you need something to read from those buckets. You got a writer and you got a reader. It's just like any other file, right? So how are we going to do that? So we go back in and we say, hey, I got a word list and I actually want to recurse on it. Recurse means I want to call myself again on it versus I just want to do this on my own. So in that first pass, because you only want to execute each bucket once, right? You don't want two reading off the same bucket. That's a little inefficient. Unless you do, that might be another approach. So you go bucket 0, that's your initial, and you increment it to bucket 1. And bucket is just a way of thinking about stuff, like in hash tables. I see my video is a little messed up. Give me 1 second. All right, there, I should be nice and clear now. So let's think about these buckets, right? Just an index, and it's just a file. It's just a way of thinking about it. Like if you learn about hash tables, you learn about buckets, but it's just a way of a container of some kind. Just a way of thinking about it. So here you got bucket, which is 0.words, which is in a temporary directory that you'll see that on my GitHub. I'm not putting everything in here because this will go on forever, but you'll see this temporary thing, and then in your cleanup function, you're going to clean out that temporary directory so it doesn't kill your file system. And you're going to echo that first username into it, and then the second, and the third, and the fourth, and the fifth as it keeps looping and looping and looping. And on the first pass, and only the first pass, after you've initialized the bucket for that particular process, you're going to go ahead and call the SMTP sweep.bash, give it the word list from the path, the absolute path to it, .words. You're going to have all the commands saved up that you initially put in that should be passed into the child process. Not everything is. And once again, please refer to the GitHub after if you want to learn more about that. It's not the main point of this. And then you're going to give a nice, cool little name, say child-1, child-2, et cetera, et cetera. And then if you have 10 buckets, roll back to 0. So the next time you go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And first pass is false, so we do not execute this guy more than 10 times. If you wanted to go more than 10, challenge for you, just increase the number here or make it an option. Oh yeah, and there's that meme. All right, so reconnect. Let's move it over. How does reconnect work? So I spam 20 commands out and it boosts me, but I want to try the next 2 million that I have on my word list. And the way you do that is now you can't just write out. You got to say, did my write work? And if it did not work, I got to do something about it. And we're going to do something about it. So this first part here is you're doing, see, a million ways to write an if statement. This is just to demonstrate that. It's not typically how I do it. I like to use double brackets, double square brackets. But this is one way of doing it. And you say, hey, did my command work? If it did not work, then we got to reconnect. If it did work, I'm done. And you just pass the command name in here and the command, and it'll echo out that command. Remember, it doesn't need to really return much more other than the fact that, well, normally you'd say if it worked or it didn't work, but now we reconnect if it doesn't work. So here you go, echo-e, sends out that. This is very familiar. This is how you reconnect. The logic's a little bit different than how it initially sets up that connection, but here you are just reopening that connection, testing the connection, checking the file descriptor, all that stuff you're familiar with, logging what happens, always log, 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 log. And then here you do exactly what you did to get that first message that you got that says, hey, I'm an SMTP server. But remember that you just need to understand the protocol where you're talking to. You're going to take this idea and apply it somewhere else. And then send command. What we're calling this again? Why? Because it failed. This didn't work. We want to send it again so we get a chance to work with it. Otherwise, you're going to miss a lot of different words. Every 20 words, you're going to miss the 21st or 22nd, 23rd, however it falls out. And that's no good. So you're going to send that command again. And if it fails, yeah, you'll keep looping. Oh, well. And here, obviously, this test connection attempt will actually exit you if you reconnect and it doesn't let you connect. Then you're done for real. All right, so got another question break. We're doing okay on time, which is great. So we have an amazing presenter coming up next, which I can't wait to see. Does anyone have any questions about all this stuff they're absorbing? Any at all? We're going to be starting to wrap up in a second. And when we wrap up, right after that, I'll put in the GitHub, I'll paste it in, or you can take a screenshot when it comes up, whichever you prefer. All right. No questions. That's great. So stealth, obfuscation, and the future. What can you do here? What can you do? So the stealth, you don't need a file when you're doing this. Just not needed. You just put it all into your bash session. And then when someone does some forensics, they're not going to find a file with your commands. Obfuscate. You can mask what that command is and have your script decode it and execute it. Let's see. And then you can even use SSH. You can embed a command in SSH, a whole bash command, if a bash shell is what opens by default on that machine. Otherwise, you might have to open up a bash shell as part of your script. But it can go ahead and send that command over SSH if you have valid SSH credentials or some kind of exploit that gives you a shell, and use that to execute your program. And now you're doing it in the context of them. You don't have to go through proxy chains, which is slow. You don't have to use a SOX proxy, which is slow. You don't need to reroute things with bash, which is, not bash, not exploit, which is slow. And you're now operating from the context of the network internally. What that means is if they have special rules that apply for internal clients versus external clients, you might have more privileges or less throttling, which is great when you're trying to get through large word lists in the future. So the future. Has anyone heard of WSL2? WSL2. Anyone? So WSL2, that is Windows Subsystem for Linux 2. WSL2. Does anyone see where this is going? Calvin? Yeah. Bash works on Windows. I haven't tested this out yet, but even if it doesn't work now, we see Windows getting more and more POSIX compliant. All of your bash skills, all of this is just another thing that defenders are going to have to defend against. And now, yeah, Windows is a Linux kernel. If you look a little bit about what's happening with the trends in the talk, nothing official yet, but it's just getting closer and closer to that. Yeah. So now you have a new tool that works on Windows, not just Linux. And yeah, I know, what was that new shell? Does anyone know that new shell that Kali likes? It has some way to do something similar, dev TCP. It's not the same thing. Great shell, from what I understand. I just know bash really well, and it's useful. It's everywhere. It's ubiquitous. This one isn't. But, I don't like cmd.exe. I don't even like PowerShell, but I know enough of them because it is what it is. Yeah, ZSH. Thank you. Thank you. They're all awesome shells, and you use whatever you got. And bash is frustrating. It makes me feel like Baby Yoda without the Force, but it's your tool. So now it's going to be on Windows, it looks like. And there's going to be more and more unlocked as Windows gets closer and closer to Linux. All right, so yeah, I'm gonna scoot on over. So take a screenshot if you want, or I'll just paste this into the chat right after. This is my LinkedIn. Please reach out to me. Actually, I'll just go over like this. Yeah. So reach out to me on anything. I'm a lurker on Twitter, but I'm trying to get a little bit more present. My LinkedIn says so much more about me than what I was going to talk about here, but please do reach out, read the GitHub, take the code. It's public right now. I'm sure you guys are downloading it as we speak. It talks about how to set up the lab, which is great. Make sure you listen to that lab talk on tomorrow. That's going to be very useful. I've listened to his talk about labs, and it's very useful. And does anyone have any questions here before we end this presentation? All right. No. Well, yeah, thank you guys. I appreciate you guys. You're a great audience. I love teaching, love sharing the information. And yeah, and hey, Calvin, if you have more questions, reach out to me on LinkedIn. I'll share my email. So yeah, proxy, good question. Defensive perspective, what should we look for? So are you familiar with PS, the PS command? So yeah, that's what you want to look for. So every time you run a bash process, it's there. And if you see something super long, someone just dumped in a giant one-liner, you might want to take a look there, especially if it has dev TCP in there, or some strings that are garbled up to become dev TCP. But be careful if someone injects some bash code in there, that'll be reinterpreted by you, bam, you got a problem. But yeah, look at the process. That's all. Any other questions? Also, plain text. See a plain text talk, and almost everything should be encrypted in your network. If you're working at a great place, that would be another sign. I mean, people with dev TCP, no one's going to write an encryption module in Bash. I mean, you might use other Bash tools, but if you don't have those installed by default in your network and someone's using native Bash exploit, they're probably just going to be using plain text protocols. All right, so I'm going to dump the OneDrive link. I want to drop my all the links up here in the chat. Thank you, everyone, for attending, and I guess you have a little bit of a break before the next presentation. Oh, very important. I'm sorry. Like them or not, yeah, internet is not a luxury, it's a necessity. What you do here, you guys are going to be the protectors and the defenders of the internet. It is the fundamental equalizing power. Not everyone is as fortunate as you or I, and this is what gives them the tools. So what we do enables the future. And people are starting to understand that. What you're doing is going to be more valuable than you can possibly imagine as time goes on. I'm just a software developer with a cybersecurity bent, and we understand how important it is. And you, info security professionals, are at the forefront. You're going to be the military of the future, believe it or not. You just might not be collecting that paycheck from Uncle Sam or whatever your uncle is in the country you're at, but you're the defenders of this important necessity. All right, so once again, thank you, everyone.